Nice. So here we go. We're talking about. You guys okay? You need me for something? Okay. I don't mind. So what we're talking about today is section 4.6, optimization. So like I like to pretend my company's making boxes for Amazon, right? So I'm making cardboard boxes for Amazon, and Amazon has demands on the volume of the box, right? So they want a box of a certain size, yes? But what do I want to do as the company making the boxes? I want to minimize the cost to make the box. I want to make it as cheap as I can so I can sell it to them for a profit, right? So I've got restrictions on the volume, but I don't have restrictions on how much cardboard I can make, right? Because I can get that same volume several ways, right? So that's the idea here. We're going to have some kind of information that we know, and we're going to try and minimize or maximize something, either to make a profit or to find the best amount of quantity to make that kind of thing. So optimization, there's really three problem types that I like to deal with. There's more, but the ones I will ask you to be able to do are just XY problems, geometry problems like the box, and minimum distance problems, min-max distance problems. That's the part I probably won't get to today. The min-max distance I'll probably have to do Friday. Okay, and they're very difficult, and of course that's the one I like to put on the test. I don't like to put the easy problems on the test. I do put one easy problem on the test. So the first page it says name, right? So that's the one easy problem I like to put on the test. But the rest I like them to be difficult. You know, you'll feel better about yourself finishing a difficult test. So we can take a look at the book right away for an XY problem. I have a step-by-step, but I want to do a couple problems before I write the step-by-step out, okay? So 4.6 exercises. Like number 4, the sum of two positive numbers is 16. What is the smallest possible value of the sum of their squares? Right, so just x's and y's. So if you haven't figured it out, there's going to be two variables here, x and y, or whatever letters you choose to use for your variables. And then you're going to try and create a function of x from those pieces that you get, right? So sum of two positive numbers is 16, right? So this is so this is my xy problem. This is 4.6, number 4. So x and y belong to positive real numbers. And I know that x plus y is equal to 16. And then I want to minimize, I believe, what is the smallest possible value of the sum of their squares. I want to minimize x squared plus y squared. So you can see the first part of my step-by-step is read the problem, right? If you can, draw a picture. That would be more towards geometry. Find an equation. I got an equation, x plus y is 16, and find your function of x and y that you're trying to optimize, minimize, maximize, whatever they're asking. So that's my first step. Second step is take the equation and solve for y, right? So what do I know about y? Y is equal to what? Yep, 16 minus x. And plug that into your optimization piece to create a function of x. So now I have f of x is x squared plus y squared, right? And that's what I want to optimize. So in this case, minimize. Right? So you can see my step-by-step coming. Come up with an equation, come up with an expression to optimize, solve for y in your equation, plug it into the two variable function to create a function of x, and then do what? First derivative test to get a critical, second derivative test to show, answer all of the questions, right up to conclusion. I'll write all that down later, okay? I'll write it down later. But let's finish the problem here. So now I have a function that I want to, and I can simplify this. It's not that important that I simplify it right now. So I'm just going to take the derivative right away. So f prime of x is 2x plus 2 times the quantity of 6 minus x to the first times another negative 1, right? Derivative of the inside. Yes? So I get 2x minus 2 times 16 minus x. So I get 2x minus 32 plus 2x. I get 4x minus 32. Sweet, easy, right? Yeah? So take a look at what I get. What would I get? So f prime of x is equal to 0 gives me what? X is what? 8? Nice. So remember, I had an x and I had a y, so now I have to figure out y. Well, it said x plus y is 16, so y is also 16, right? So x equals 8, sorry, y equals 8, right? The sum of x plus y is for sure 16. And then what is my x squared plus y squared? It's what, 128? 64 plus 64? So I've answered all of the pieces, all right? I've answered everything that they talked about in the problem. I'm still going to write a conclusion. I want to summarize it all at the end. But I want to verify that I have a minimum by using the second derivative. So and that's pretty damn easy, isn't it? What's the second derivative here? 4. So if I plug in 8 to my second derivative, I still get 4. So it's positive for sure, right? So in my conclusion, I'm writing, since my second derivative is positive, right? And positive, I'm not going to say this in my conclusion, but I know I have to have a min, right? I know it's got to be minimized. It's kind of fun and fun, when I say fun, it's fun in quotes, right? It's fun, math fun. If I think about other positive numbers summing to 16 and what happens with their squares. So for example, x plus y, x squared plus y squared, right? If I can just start writing some values out, how about 1 plus 15, isn't that 16? Right? And then if I square those and add them, I don't tell me, give me a second. 1 plus 15 squared, 226, right? Remember, and I want that piece to be minimized. And look at what I got from my value when I minimized, right? 128. So I could do like 4 and 12. Again, my sum is 16, but when I square it, I get 144 plus 16, right? I get 160. You see, I'm getting closer to that min value. You see what I'm saying? I'm just playing around with this. I'm not saying this is what you have to do, but that's the idea. So XY problems are easy. There's one really super challenging problem in the book. If you want an extra challenge, I don't know who would, but which one is it? I'm trying to find it. I got a piece of wire, and I'm going to cut it into 2 pieces. Is it in here? Maybe they took it out. I think they took it out, which is a shame. It's a really tough problem, but I got a piece of wire, right? Let's say 3 feet long, and I cut it in 2 pieces, and I take one of the pieces and bend it into a square, and I take the other piece and bend it into an equilateral triangle. And I want to try, so now I know the x plus y is 3, right? And I want to try and maximize the area of those pieces added together. Very, very, very tough problem, but fun. Again, in quotes, fun. Let's do a geometry problem, and then I'll write out my step by step. Okay. So the geometry problems are like boxes. I like the box problems. 22 is interesting. It's pretty damn easy though. Let me see if there's another one. Box with a square base, packing crate. Oh, here's one. A farmer wants to fence in an area of 1.5 million feet squared. So farmer on the land. I want to fence in an area, I don't know, for cows, whatever, right? So I'm gonna create that rectangle fence, but I want to split that area in half, right? Maybe keep the angry cow away from the other cows. Maybe, I don't know. So now you can picture it. Can you picture it? This is number 15. So I've created some rectangle with fencing in my land, and I separated it with another piece of fence here, right? So I'm looking down from above ground, right, from the air. And I know that I'll call this side y, and I'll call the base x. I know x times y is 1.5 million feet squared, so an area, right? I will keep the units in mind, but when I'm working in the problem, I don't bother writing the units in there. So I know areas is million feet squared. I know the side of something would be millions and millions of feet, right? But I have to figure out the piece that I want to minimize. I want to minimize the cost of the fence. So meaning I want to find the dimensions of the width and the height that will give me a minimum, right? So I want to minimize, how many x's do I have? 3. So three lengths of length x and 2 of y, right? So there's my first step. Get me a picture, read the problem, get me a picture if needed, find an equation, find an expression to optimize, right? There's my first step of my step-by-step. Yes? Second step, solve for y in your equation, plug it into the optimized piece to create a function of x. So what do I get? I know f of x has got to be 3x plus 2 times, what, 1.5 over 3, over x? Sorry. So second step, take your equation, solve for y, plug that value of y into the piece you're trying to optimize to create a function of x. Right? So that, what is this? 3x plus 3 over x. So there's my function that I'm going to try and find the minimum of. How do I find a minimum? First derivative test to get the critical. Second derivative test to show that it's a min, and then answer all of the pieces. How big is the fence? What's the area? What's the perimeter? And then make your conclusion, right? Yes? And I have a feeling you might be really close to overwhelmed right now. I have a gut feeling, because it usually happens right around this time. This stuff is tough. Not really. If you break down to the step by step, it's not tough, but you have to practice. You can't, the first time you parallel park shouldn't be with real cars. It should be with the orange cones, right? Maybe with an egg on top of each one, right? So you got to practice. So you got to be disciplined enough to sit there and do a problem, even if it takes an hour. You got to be open enough to ask for help if you're stuck, right? And there's lots of ways to get help. Me, Dr. Early, Math Learning Center, your study group. Yes? Okay, so we got our function we're trying to minimize. Let's get our derivative. Who's got it for me? Good. 3 minus 3 over x squared. In this case, I will want to get a single fraction so that I can factor it. I get 3x squared minus 3 all over x squared. Of course, I get a critical from downstairs there of 0, right? But remember what x is. It's the length of the fence. If I have a length of a fence of 0, the height of the fence has got to be infinite. Because they have to multiply to 1.5 million feet squared. So x equals 0 doesn't make any sense. But what do I get upstairs? What criticals? Plus and minus 1. Okay, the negative 1 million feet doesn't make sense either for fence. So the only critical that makes sense is x equals 1 million feet. I mean, that's a pretty damn long piece of fence, right? But, I mean, the farmer could have a lot of bad teeth. I mean, lots of acres. Get it? Get it? Bad teeth, acres. No, forget it. Good. So now I know the length of x. I still have to find the length of y, right? I also should find the total perimeter, and I should also make sure that everything gives me 1.5 million feet squared for the area, right? But I also want to double check that this x equals 1 is going to give me a minimum in the second derivative, yes? So f double prime of x, who's got it? It's easier to use this version for me. So second derivative of 3 is 0, right? Derivative of negative 3x squared is negative 3x to the minus 2. I want to bring down my power and then subtract the power, right? So bring down the power and then subtract 1 from the power. So I get 6 over x cubed. Yes? And of course, f double prime of 1 is 6. Positive. Positive, people. Smile. So I must have a minimum. X equals 1 must be a minimum. Right? You following? Everyone okay? Step by step is not too difficult, right? Get an equation, get an expression to optimize, find the first derivative, find a critical, answer all of the questions, and verify that that critical is a minimum with the second derivative, can make your conclusion, right? There's my step by step. So I still would have to find, so I got x is 1 million feet, right? X times y is 1.5 million feet squared. So y must be 1.5 million feet. And my perimeter is what? 3 times 1 plus 2 times 1.5. So that's 3 plus 3, that's 6. So 6 million feet is the total number of feet of fencing that I would have. And I don't feel like writing the conclusion up, so I won't. But you will on the quiz or the test. Oh, you won't have a quiz on this material. You'll have a chapter 4 test. So you're going to have a quiz this Friday on 4.2. You're going to have a quiz next Friday on 4.3, first derivative, second derivative, and you'll have a test on the following Friday on all of chapter 4. It's almost over. You won't remember the pain. Do you remember how painful it was when you were born? No. You know why? Because life is good. Even when life sucks, it's pretty damn good. And that's the thing that's going to happen to you when you graduate. When you graduate here, you won't remember this Calc 1 pain. When you graduate from university and get a job and you're making maybe, let's say you start making $40,000, $50,000 a year, you won't remember the pain from this Calc class. I'm telling you, you won't. When you go for your master's and then you start making over 100,000 a year, you definitely won't feel this pain anymore. So fight through it. Nice. I want to look at one more type of problem, my min distance problem, and then quit for the day. I don't think I'll get this one completely done, but I want to at least show you the idea. Oh, should I write down the step by step? Do you want me to write down the step by step? Yeah? Yeah. Okay, sorry. I'll do that. I'll do the min distance problem next time. I'll just do my step by step here. So this is a step by step for optimization problems, right? So step one is read the problem and see if you can kind of discover an equation and an expression to optimize, right? So an equation in x plus x and y, right? Looking for an equation in x, y, and an expression in x, y to be optimized. Maybe they'll ask for a min, maybe they'll ask for a max. In my other class, I have a student named Min and I have a student named Max. So I kept saying, maybe you have to find a min or a max, and they kept going, what? What? Step two, solve the equation for y and substitute it into your expression to create a function of x. Dr. Early does this problem differently than I do. He takes the equation and gets the derivative implicitly, takes the expression, gets the derivative implicitly, and then puts them together. So there's lots of ways to do this. Okay, this is just the way that I've seen most students be successful with it. Step three, and again, you have to. On your formula sheet, you need the step-by-steps. You need a couple of example problems, probably 3 example problems. One with an XY problem, one with a box problem, one with a min distance problem, right? So there's not a lot of room, I know, but make it a work of art. Make your formula sheet a work of art. Step 3, find f prime and the C1 value. There might be more than one, but, right? Find f double prime of C1 to verify a min or max. Step 5, answer all of the parts of the question. And finally, step 6, make a conclusion. Beautiful. So I'll just set up the min distance problem. You don't have to write it today. I will repeat it all next class. Okay? So you don't have to write this today. You can just listen. In fact, let me stop my recording so at least my memory won't run out.